Hey, can you guys hear me? Hey, can you guys hear me? Hey, can you guys hear me? I gotta mute this other stream. Oh, I muted it. Okay, so I want to try and work on the type checker for the new compiler. I'll show you guys a couple things. So basically, let's see. Currently, the compiler basically it's got a pass at the start of a type checker. That's about it so far. So if I disable the type checker, let's just pass like a test file. This is just like a basic syntax test. If we add the D flag, it'll just dump the contents. Basically, I've got a test backend. Let's open it up. I've got a test backend which basically works just like V format in the current compiler. It just converts the AST straight back to V code. So if I run this on the current compiler, and output it to just text file, you can see this is what it output. Can you guys read my screen, or should I make the font bigger? Sorry, just give me a tick. I can't even figure out how to make the font size bigger. Oh, there it is. I had size in two different places. The size here and size up here. That should do it. Yeah, that's better. Okay. Has to be a decimal. Great. Ah. What was that? Alright, that'll do. Sorry about that. Typical me not being prepared for anything. Alright, so basically when we run this command, this is all the V code that gets generated from the current compiler. Just think of this like V format basically. So if you have a look through here, actually let me rename this to V so we can see that highlighting. So you can see that this is mostly complete. There's a couple things missing, like interfaces. Sorry, not interfaces. Overloaded methods, not implemented. And just some little things which I haven't done yet. But generally speaking, the pass is like 99% complete, I would say. There's a couple bugs I keep finding, but besides that, it's mostly there. So the idea is to go from SSAIR to like machine code, C backend. So I'm just working on the type checker at the moment, and I want to make sure that it's done in a way that will make all the next stages as simple as possible, basically. In the current compiler, types get stored into the AST. Let me open up the new type checker. Okay, so in the new checker, I'll just give you an overview of what's going on here. For starters, I've got this deferred struct in enum. In the current compiler, all types get registered in the parser, which is not a good idea, since we want to try and separate types from the parser. The parser should just parse, basically. So we end up with a problem. Because types haven't been registered yet, we can't assume that by the check stage all types are known, because they're not. So that's a problem, because types rely on other types. So if, for example, the struct field has another type referenced in it, that type might not have been registered yet. So we're going to do this, basically defer. I'll show you the example for structs. So this is the struct declaration. And you see this call to the later function, later method, sorry. Never mind this. This will probably change. It's probably not going to be using function literals like this. It's probably going to change at some stage. That was just to get it working as quickly as possible. So basically, it registers the struct with no type, just a name. You can't assume that the expression will work because the other types might not be known yet, basically. And then we defer setting the fields, running the expression on the fields until all type names have been registered. I don't know if that makes sense at all. Probably doesn't make sense. But basically, it's a bit of a tricky thing, and you end up with even bigger problem with consts. Some constants have other constants, or they depend on other constants, and that can be a bit of an issue as well. So at the moment, it just defers everything, but I will change it so that it'll look up exactly, for example, if a constant doesn't rely on another constant, it should be able to register that straight away, or it should be able to type check it straight away. So there's a couple of ways I can do that, but I'm not going to worry about that for now. Basically, for now, I'm just fixing bugs. So, and I'll clean up and fix that stuff later. That's more like a optimization where you don't want to defer everything, just the things that you need to. All right, so let's have a look at the current state of the checker. I'm just going to turn it back on. Also, everything in the new compiler is going to be parallel from the start. The parser, the checker, the generation stages, IR generation should be able to be parallel. But you can turn that on and off with this flag. For my testing purposes, I don't need to use parallel. All right, so let's run this. We see we ended up with an error here. Is it cannot find field or method use case for type tuple. Tuple type is a type added just for multi-returns. It's only the compiler uses it. It's not a user-facing type. So, and you'll notice that error positions are wrong. That's going to be fixed. They're right if you look at it in parser, but they're not right if you look at it in checker. And the reason for that is to do with this token.file struct. This is used to store the positions. I'll show you what it is. So we have this file struct and file set. This stores all the line offsets. So basically, the benefit of this means that instead of storing like a position struct, which has the column, the line number, and the offset in every AST node, all we need to store is a single integer. So, and then whenever we need the full information, we can call this method here, which converts this pos, which is just the alias, to an integer. It converts this to the position struct, which will have the file name, offset, line, column. But at the moment, I'm not using a file set, which will properly calculate. It will add like a base, so base again offset to that integer, so it will know exactly which file we're on. In parser, we're using this directly, and we're creating this in parser, so we know exactly which file we're on. But in checker, it doesn't currently have a way to, it needs to use this file set, which will have the correct base, and then it'll get the correct file, if that makes sense. Basically, it just doesn't work at the moment. So we're just going to go through and start fixing these errors. So what is this error? Let's have a look at this file. Field or method use cache. So you can see the error is this. It's trying to access this field use cache, and it thinks it's a tuple. The reason for that is my assign statement does not handle this properly. So if we look at the assign statement code, let's see what's happening. So basically, it's saving the type as the type it got back from evaluating the expression, or type checking the expression, which is a tuple. So what we have to do is, if I have to do something like this. Actually, we might not need that. Let's open up that tuple type. Oh, it's right here. Okay, so it's just an array anyway, so we can use that. So let's get rid of this. Let's make this mutable. Actually, no. Let's just do mute expression type. Let's call this expression type. Return type. Just make this expression type for now. If it's a tuple, let's make the return type equal rx type dot types. And let's do I, because it should be the index of the left-hand side of the assign statement is like the variables or struct field names, and the right-hand side is the values. And then let's set this to return type. I don't think this does anything right now. This assignment will be an assignment check, so it'll make sure that the values are compatible. But I think currently it does nothing. Good. Okay. Let's see what happens now. What have I done? Oops. Typos everywhere. Typical. And this is expression time. Expression type. Okay, so we've moved on from that previous error with a new error. Cannot find field or method okay for type enum. Let's have a look in this file. Okay, enum. Okay, so I'm guessing it's this. Let's have a look what's going on. So this is the code that handles selector. Well, hang on. This is this. Oh, fuck, stop doing that. This is the code that handles the selector expression. Basically, then it just looks for a field or a method. Now, at the moment, let's open up the parser and let's go to enum values. All right. So you can see at the moment I left a to-do here to see if I should use its own node, an enum value node, or a selector expression which has an empty left-hand side or right-hand side. So basically, currently enums, so like .ok would end up being a selector, and the left-hand side will be an empty expression. So we can either leave that how it is, or, well, this is an easy fix. What we could do is, well, I've already done that. At the moment, if the left-hand side is empty, the only time this condition will occur is if it's an enum. Later, we can change this to be its own node if we want. But for now, we'll just use this. It's so simple. For this small check, I don't see a point in adding a node for now. We can always do that later. So we're just returning an int. Obviously, it doesn't. Let's print the name of this enum and see if it's got the right. Let's do some investigation. Let's print the name of this type. Let's just add the name here. All types have a name method. If we have a look at that, you can see here we've got all our different types, like each one has a name method, and if we call type is a sum type with all the different types, it has a name method, and then each type has a name method. So okay, the name is parser state. Is that the right enum? All right, so it knows which enum it is. And it's okay. So basically all we need to do is look up the fields of the enum. So we should just be able to do this. If it's a type, find field or method, we should be able to do this. Let's look up the definition of the enum. Looks like we didn't even pass the fields into the enum. So we'll start by doing that. Actually, how are we going to do that? Let's look at the parser. See, this is another example of something that's missing from the parser. Oh, hang on. We have that in the declaration. Okay. Shit. All right, so so we've only set the name, so that explains it. So all right, let's go back to types. I'm going to add a type, or I've already got it here, field. What's that used for? Structs. Well, let's just use that for now. I don't know if we need type exactly here. We can possibly use another type for this later. Well, let's just use this for now. So let's go fields. Okay. Well, let's just do that for now. What did I do? Oh. It's always a typo. Okay, so now that we've saved the fields, we should be able to look it up. So let's go back to our selector. Selector expression. Actually. And then, see, for a normal type, which an enum comes under type, it does find field or method. Find field or method. So basically we should just be able to do if t dot, let's just loop them for now. We can add a method or a helper for this later. For field t dot fields field dot name equals name return, let's just return the integer for now. And let's just add a little found enum, found name for enum t.name. Let's just do enum. All right, here we go. So we see here we've progressed past our other error. Where is it? Let's just grab it for a sec. So this was our error before. OK for parser state. So we've progressed past that. You can see how easy it is to, I think it's easy. You can see how easy it is to add support for types. And this is basically the whole of the selector expression. You can see all this junk here, which is going to get removed. It's only going to get cleaned up. These two things here are for flag enums. These are compiler magic at the moment. Cannot find field or method len for alias. This is a good. Let's just look at let's look at void pointer just so you can see what's going on here. These are all the built-in types. Well, not built-in types, but the language types. Void pointer is just an alias, so a pointer for void. That's why it says, that's why it looks like this. So len. I need to fix those error positions, but we can see here it's should be an easy one, but I may not have done variadics yet. So in the first implementation of variadics, they were using like a custom generated struct because it was faster that way. But the only problem with that is you don't have all the nice array helper methods for like iteration, for field access, and when you want to pass, or when you want to do like pass them to another function or pass it to where an array would go, then you have to create an array. So we ended up just using arrays. But for the new compiler, I'm thinking we'll use the tuple type and we'll add the tuple type can have all, well, this is I'm thinking it's not set in stone, but that type can have all the same helper methods as an array, but it'll be faster because there's no like allocation, it's just fixed. And then if it ever needs to get used in a place where an array will get used, it can get converted to an array. That's what I'm thinking anyway. And let's see what's going on here anyway. So basically variadic's not implemented. That's why we're getting this pt.len error, because it's trying to do void pointer.length, not variadic.length or array.length. So let's see what's happening. Let's go to the parser. Let's go to parse type. Oh, so this is where the variadic types are parsed. Okay, we're just using a prefix expression with ellipsis, which is not too bad because there's only one reason this will end up in an argument for variadic, so we can use that for now. Yes, what will we use here? Let's use this for now. So let's check the function declaration. So we have this method function type, which, let's look at it. Sets the variables, well, it inserts the arguments into the scope. So we should be able to do, so let's try something here. What is it? Let's have a look at that. Oops. Oh, hang on. Oh, so this is what we want. My bad. Oh. So let's add a field to this parameter, or we can add it to the function declaration. Let's just add it here for now. Oh, let's actually, we don't even need this. Let's add it to the function type here. I'm using optionals here for the return type, and in the AST I'm using empty expression. I feel that empty expression might be faster than using optionals, but this might be more convenient. So I haven't decided which is the best to use. I wonder what you guys think. Well, we'll figure that out later. So let's do is variadic false. Let's do y. Let's do is before we do that, let's do if I is less than len. Let's do a check error. We'll fix the error messages later. Must be last. Yeah, we'll fix the message later. And I don't have a standard error function yet. I only have one error with position, which takes that integer I was talking about earlier, the one that gets turned, it's the single integer that gets turned into the position struct as you need it. So for now we'll just pass 0 here, but that would be oh, I have to store the position into this, which I haven't done yet. And let's do this. Ah. What is this? It looks like it's less than wait, 1. Yeah, I think that's right. Okay. So now actually let's do it a different way. Yeah, we can do this much simpler. We can do this much simpler. Let's do it like this. let's do it like this. So if it's variadic, we will do this. We could set it to an array or a tuple as well. Let's do prime type equals tuple. I would like to use that over arrays if possible. Or some let's just make it an array for now. We'll fix this later. We're gonna make it an array. Element type equals type. Because now it should be an array, so it should just work because array does have a length field. So we're just saving a whole bunch of fucking around at the moment. But this is what I'd say. You can see how things could become a mess real quickly, or they could be done nice in a nice way. So I want to just make sure that we take time to do this properly. Obviously, there's a lot of messes here at the moment, but it's going to get cleaned up. And I've closed it like an idiot. Where was I? Yeah. And all right, so we've moved on from that era, or have we moved backwards? Have we moved backwards or have we moved forwards? That is the question. Where were we before? We may have moved. Let's just comment this out again. So I think we did move forwards. Yes, we were stuck here before, and now we've moved all the way down here. Cannot find field and method flags for alias. Oh, let's have a look at this. So, pretty straightforward. Builder is an alias to a U8 array. And I didn't even know that U8s had a flags field. Is that what it's on? Let's do built-in array. Where is it? Oh no, hang on. Oh yes, we do have flags, array flags. I didn't know that was accessible from user code. Is that supposed to be accessible from user code? Anyone? Anyway, back to where we were. So it's not finding this flags because flags is on the array type, and we've got a Alright, I know what's going on. So basically we have alias to U8 array, and we're looking for this flags field. Now it's not on the builder, it's not on your, well, it is on the array. Let's look at the code. So types fall through here. Arrays, 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 and it looks like arrays here. So let's do well, that's not gonna. Looking for field or method length on rune. No, that's not it. No. I don't find field method flags for alias. Okay, so I know what's going on. This is fine. It's going to be the alias code. Okay, so we don't even have code for. Well, we don't even have any code for that. So that would explain it. Well, let's add that. If t is alias, what we'll do is first we'll check if it exists on the alias. If it doesn't exist on the alias, then we'll check if it exists on the parent type, and that should work. So you can see how simple this is going to be. All we're going to do is, let's just copy this. Now I'm sure this could all be consolidated soon. But for now, let's copy this. So let's do. So let's look for, if we find it on alias, we return it. If not, let's look for it on the parent type. So let's do, actually, let's paste that again. Let's just paste. Let's copy this. Let's look for it on t.base type. Well, it's already an alias, so we have the field base type. That should work. Now we don't need to fall through to here. If it doesn't find it here, it's going to do another search. Actually, no, this is the standard search. Where is it? He's looking for methods. Actually, I think that should work. Let's try that. No, this is gonna be infinite recursion. Let's search on the base type. I don't think we need to, because this handles let's try that. Is it alias no, it should be parent type, I think. Parent type. Oh, it looks like we've progressed. Or have we digressed? Looks like we've gone backwards. Or have we gone backwards? It all looks the same. Where were we before? We were... Let's comment this out. We were looking for flags. Flags. Let's open it. Let's open a new thing so we can compare. Looks like we. Oh yeah. Let's put that over here. Okay. So we progressed past flags, which was this error, and now we're on another one. Cannot find field or method set for enum array flags. Have I broken something else? No, I've progressed. Let's see. Set on array flags. Set. Oh, beautiful. So we just moved from here to here. That's lovely. We moved from here to here. Fantastic. Let's see what's going on. Let's close some of these. That's better. Okay. All right, now, so basically that's another flags thing. So all I need to do is add set here as well. So let's just do, let's change this to if name in, actually no, that's not gonna work. Let's just do, well, first let's look for fields. And then we'll look for this after. So what was it? Set. Does set return anything? Set returns nothing. I don't think. It's probably. Hang on, let's have a look at that code again. No, it probably doesn't return anything, but it was erroring. Let's return void. This is something I'm not sure if I like. Because currently the expression method or all these methods need to return a type. For example, let's go to checkout expression returns a type. Now, it's true. If it's an expression, it's going to return a type. But I don't know if I like the idea that of returning void here. I mean, the other thing is, which I pondered, if we might need, if at some stage we need more information about the types, for example, we might need some information to say if it's a constant expression or something to do with the some extra information we might need with it. We could return something else here, and then of course we could either have a type or not instead of void, but for now we're just using void. And all these types in universe is, I will explain something else in a second. In the existing compiler, maybe I can open it up. Let's open it up and have a look. We're going off course for a sec. I go off on tangents a lot. Alex knows all about that. So. Let's open up checker in the current. Where is it? Checker. Okay. Let's look up ident. Now, in the current, this is the current type checker. This is the identifier type checking code. We can see here. Well, let's ignore all this. All right, so first we look up we're doing one scope search to look for variables, globals. All right. Then we're doing another scope search to look for global again. I don't know why there's two with globals. Constants, okay. Then we're searching for a function here, okay. Now that's just in ident. Okay, now let's look at something else. Let's look up found. Actually, it's not in this file. Let's go to function. Found. Where is it? Let's look at this. Function call. Where is it? Okay, here we go. Let's look at this. So we're doing all this to check if we have anonymous function. Then we're looking up in the functions in C.table. We're looking for it with the prefix. Then we're looking. There's a whole bunch of searches, is what I'm getting at. There's even another scope lookup here. There's a ton of searches. These are global function. Basically, there's a whole bunch of searches. There's even more stuff going on here. Let's close this. My only point is there's a whole bunch of searches. In the new compiler, there's one search. Well, there's two methods, but methods currently are stored in a map. They could get stored in a different way. At the moment, it's just stored in a map by name, the key. With the name as the key, I mean. But for everything else, there's one search, scope search. So we have a universe scope. This is what similar to how Go works. Universe has these built-in language types. Now, this is the top level, the very top level scope. The next scope down would be a module scope. Now, if you were to have, at the moment, there's no point having, so it would go like universe, module, then a function, then obviously like the scope of an if or some statement scope, etc. Now, when you search for a variable, or when you search for an identifier, it could be a variable, it could be a constant, it could be a global, it could be a function, it could be any of these things. Here, it could be a module. These are the things we're looking at right here. Could be constant, global, module, type. I'm not sure if there's something missing from here, but all these things are done with one search. Now, it'll look at the current scope. If it doesn't find it, it'll go up the scope to the module scope. Doesn't find it, it'll go up to the universe scope. Now, in between module and universe, I put built-in. That way, as it progresses searching up through the scopes, most things automatically import built-in. That's another search to try and, well, in the current compiler, it's another search to check built-in. But in the new compiler, it's a natural progression. As it searches up through each parent scope, it'll go from the module to built-in to universe. So it's one lookup, just going up to parent. And that's one lookup that the current compiler does anyway. It does that for variables, it does that for constants, it does that for globals. Plus then all the table lookups it does. So all that stuff is replaced with one lookup, which the current compiler does anyway. So that's a lot more efficient. And it's a lot simpler. What was I getting at? Oh, yeah, so universe scope, module scope, built-in scope, etc. Now, I can't think of a reason at the moment why we need a file scope, but if you were to add, well, you could have a file scope if you needed to differentiate between which file inside of a module something was declared in. If that information is useful or it's necessary for some reason, then you want to store that. If you don't need that information, then it's one extra scope, which is not really going to slow things down a lot, but it's one extra scope you don't need. If you had file level variables, then that might be one reason to have it. At the moment, we don't have it. We just have module, built-in, universe. Now, this universe here would be a perfect use of a file level variable or module level variable or something. Ideally, we don't want to use a global, and a constant, we don't have to write to this scope. It's read only, so we can get away with using a constant here. But ideally, this would be some type of file or module level variable. But this is fine for now. The other option is we need to store this in some type of state struct. But for now, this is fine. Well, where was I? I've started waffling on about stuff. Let's go back to what we're doing. All right. So where was it? Enums here. Set. I probably just didn't save this because if I saved it, it probably would work. is this? What's going on here? What have I done? Undo. Oh, I did something there. What have I done? Can anyone see what I've done? Have I done something stupid? What have I done? I thought I just changed that. I don't know. What have I done? It looks like... What the fuck did I do? Oh, hang on. How did that get there? Ah, I see what I did. Let's copy this. Undo this. Paste this here. Cut this. Just move this here. Yeah, that's probably what I did before. Ah, what the fuck? Ah, that should work now. Ah, so we've progressed on past that other clear message. Where was it? Find field for flags. So we'll progress there. Now, this is the same thing, clear. Clear probably returns nothing. So I'll set name in. I would like to move this away from compiler magic to some... I think it's still compiler magic in the current compiler, but I'd like to move it away from that, if possible. I don't know if that's possible. We could use some type of... I don't know. Think about that later. Now we're just doing this. Let's do it in order alphabetically. Let's return the line, actually. Should fix that. Alright, we've moved on again. Now we got count find field method repeat for primitive integer. Let's have a look what's going on here. Array repeat, no, string repeat. And why is this? Oh, okay, so this looks like somewhere in checker I'm returning an int instead of doing the proper thing. So let's figure out what's going on. Array index is probably returning array initialization. Array repeat. Let's have a look at the array initializer. Primitive. Okay, let's go. Alright, that's typical. That should be, maybe I've set this wrong. Maybe I've set this as the element type instead of the, let's look at this. Yeah, let's just go let's do. Let's see what we've got here. Let's just do see what we got. Oh, so we do have we got the right type. So why is it looking for it on? Hang on, what is this? Unhandled. Oh, that's because I didn't return it. Never mind. Because it's down here. If it doesn't return it, prints that. Highlighting messes up sometimes in Helix. Kind of got to do this, and then it fixes it. Oops. Why is it the element type and not the array type? So I'll find repeat for primitive. So let's see what's going on with arrays. Arrays here. I know what's going on. Let's double check. That's strange. Is there another? Why is that happening? Give me one tick. Sorry about that. Stage change. What is going on here? Array init. Repeat. Unless this is passed incorrectly. Let's try something. Let's try something. Let's just try this. Let's see. Oh, it's the same thing. Oh, let's undo the changes to this. So why is that? It's very strange. Primitive. Why have we got a primitive? That's exactly what I'm trying to work out, Daniel. Because if you look here, it's definitely, hang on a minute. Oh, oops. Yeah, that's it right there. I'm an idiot. Look at that. I'm returning the last value for some stupid reason. Why would I even need to do that? See, all right. Let's add a note here. To do check all expressions. Okay. So what we could do is this basically. So basically we just do like actually let's just comment that out in expressions. See, we don't really need to type check them all for now. Let's not do that this second because it might end up with other errors, and we're not. Let's not do that for just this second. Let's just return the array type. That should fix our error. Void. Array init void. Well, that's a problem. Let's look at the parser. I know what. Okay. I know why I was doing this. Alright, never mind. I'm an idiot. Let's leave this note here because we might need to do that. Let's move this again. Let's move this here. So basically what I was doing is for this, we in parser, we never set, see, for this type of initializer, type gets set on the array here. Now for these type, we don't set the type, we just, it has to happen after type checking. This is a name type, we can set that, but that still gets type checked here. But for this one, instead of doing this, what we'll do is alum type c dot expression. Let's pick the last one. Last. We might have to type check them all at some stage, but for now we're just taking the last one, so they should all be the same type. And here we'll return. Actually, let's get rid of that. Array alum type. That should fix it. Yeah, that fixed it. See, if we look here, where was it? Found method repeat for array. Beautiful. We've got more errors. Never ending checker errors. No. That never had a position. That's a type. It doesn't have a position. If you error, you'll error using the position in the initial array init. This has no position stored. See this array init struct? But I need to store. I just haven't stored positions. So it would just be like pos p.pos. That's a single int. That's what I was talking about earlier. Here as well, pos p.pos. But I'm not going to do that now. Well, that's a simple task. Yeah, I can use either one. Let's do first. That's fine. They should all be the same. But I will have to type check them all at some stage. Well, first is not a problem. Let's just use the first one. First, do the same. Yeah, that's a good point. That's a good point. We can do that now. We can do that now. Let's do first alum type first, and we're gonna have some sort of let's do for expression. I could just do. I don't want to use it. I didn't want to use a array substring, whatever you want to call it. Let's just do it like this for now. Let's do alum expression alum type. Yeah, we can do if first, or if, let's say, alum type doesn't equal for. Now, this is, we're going to have to think about this because is there a way to compare two sum types are the same? Can you do this? Or do I have to check? There has to be a way to do this. I don't want to check the names. But is there a way to, like this? I know that's not going to work, but um, yeah, that will work fine. That's not a problem. Yeah, that will work. That will work fine. This this will still return. Yeah, that'll work. Not a problem. But this is not going to work. I don't know if it's just escaping my mind at this second, or if there's no way to do that. To do compare types. How to well, let's just do this for now, and we'll fix this. This is ugly. We're gonna have to get rid of this. I just can't think of the. What did I do? What have I done? Ah. What is this? Now I've bought something. I bought something way earlier. Let's just have a look here. 64. I-64, F-64. Looks like, what have I done? Maybe I've universe F-64, where's I-64? I-64. I might have. Okay, that's right. F-64. Well, the error is here anyway. Because these, okay, well, in this, yeah, I get what you're saying now. These are, okay. I understand what you mean. Because these are passed as, unsigned, they are, where is it? Int literals, which may not even be. Let's do. Let's fix a couple things. Basic literal. So this, instead of turning this should be int literal. Let's fix that for a sec. Okay, now. What did I do? So we need it. We need a method that we can reuse, that will be used anywhere, that we, whatever the word, coerce or promote the integer literal into some number type. But for now, we will what we'll do is, okay, to do add general method for promotion. Actually, we need if let's add a let's call it promote type, or promote number type, or promote type. Let's just call it promote type for now. Type if or God, let's do. We need to check if it's promotable and then do it. I'm not sure what the best way to do this for now is. Let's check this case manually for now. And let's just do this for now. And then we'll make a more general method to do this. If I is in literal and first type. Now let's go back to our types, see what other methods we've got. Let's add a little helper method for our primitive time. Let's add a helper here. No, hang on. Well, his number turn t the prop start has it's so that's easy. I won't even need to do that. Only universe, no multiverse. I'm already going off on tangents, so. Keep in mind, all the stuff's going to be cleaned up. And very importantly, needs to get moved into one function for each check. I don't want to have like this check hanging around here, see this thing, and then another check does the same thing somewhere else. Like all this stuff needs to be in one place. Otherwise, we're just going to end up with like edge cases. That's really important. We need to make sure that we do that. Okay. What's this? Why? This is strange. Expecting got yeah, I thought I did that. I thought I fixed that. But why is it I-64? Am I going crazy? It's a F-64. F-64. Well, where's the I-64 coming from? Oh, I know what I did. I bet this name method is wrong. Where is it? Where is it? Oh. I haven't done floats. That would explain it. That would explain it. Yeah, that explains it. Alright, so if let's do if t.props has integer well, that should fix it. Or that will fix the name. And what have I done? Yeah, I can do that. But no interpolation. I'll fix that later. What have I done? Oh, what? Why is this here? Okay, let's fix this. This is stupid. Why did I do it like that? Why is this here? Oh, okay. Right. No, I don't think I wouldn't want to do that. Yeah, let's use a match. Uh, lol. Well, let's do L4. I think. Ooh, whoa. Let's do. Ooh. Let's do it here. Let's do. Oh. I don't even want to use prefix. What is this? Oh. All right, that took a lot longer than it should have. Anyway, where are we? All right, integer literal. So if and first element type is integer. No, this is a float. Hang on a minute. That's a problem. I think float literals should be passed. They're getting passed incorrectly, because let's have a look here. We got float literal, okay, but it's integer literal, so something's wrong. That's a problem. Let's go to the parser. Yeah, but is it formatted with a I just want to check how these are scanned in the scanner. Okay, so this is the basic. See here, you need to check if it has we need to check if it has a decimal in it. If it has a decimal, then it needs to be float literal. I don't know. Let's just do that for now. I don't really want to do this, but I don't like this. So it should oh, that's better. Now we've got the right type, so now we can promote it properly. But I don't like that, checking for dot. But we're either got to do it here in the scanner or in the parser. It has to happen somewhere. So, except in the scanner, we're already. Does the vScanner break? Let me check something. Where is it? Yeah, I'm actually. Let's check something for a sec. Whether this should be done in Scanner or not. Let's forget about that for now. Let's just leave it like this for now. Alright. Let's check vAnalyzer. You've just reminded me. Okay, we do have that. Let's do... I think I had it here, vAnalyzer. Is it working? It's not working. It was working. But now it doesn't do anything. That's strange. Yeah, my completions has completely stopped working. Oh, it timed out. Interesting. Well, we don't need that for now. So else. So we can, instead of doing 2 checks for integer and float, we can do this. Let's do this, make our lives a bit easier. Let's do where is it? Is number literal. Actually, let's leave that. Let's leave, we need this one too. This number literal. This could be int or flow literal. Now, turn false. Okay, so we got that. Now instead of that, we can do if I want type is number literal, and instead of integer, we'll check number. T.props. Hang on, this is stupid. This should be here. And this should be as let's check inverse. Where is it? These are their own types. Oh, that's all right. For now, we'll just use that. Okay, let's get rid of that. Okay, that should work. What did I do? This number. I think that should work. Oops. 398, 398. there something else here before? Okay. We have found that's that's wrong too. Look at that. That should be that's bizarre. What is going on here? What is going on here? Obviously, stuff something up. I did have untyped and uns. Why am I using? I might remove those and they can use primitive. But that's why I had this untyped here. I think that's why I had that. But let's see what we've got here. Integer unsigned. How did we end up here? We should return here. Integer and unsigned. Integer should return here. How on earth do we end up here? Can anyone figure that out? Oh, no. Makes no sense. Integer unsigned. Integer unsigned. How the fuck does it get here? So there's a U8. Oh, I was supposed to remove that. Well, that's not going to make a difference. I'm very confused at this point. Is that not matching because it's integer and unsigned? Can you set them like this? Can you set properties like this? This is weird. Let's just I don't get it. How the fuck is that? Excuse my language. I just don't understand how it's ending up here. How is it ending up in this branch for integer unsigned? You should end up right here. Unless the match is fucked or something. Oh, I think this match doesn't work. Let's try something. I think the match is broken. You can't. I don't think it works like that. When multiple flags are set, I think it's failing on this. That's what it looks like to me. Oh, that's better. It was match. Match doesn't. Match is a bit blocked. We found a bug with match. Well, actually, no, it's probably not a bug. You just have to check. Like if you put pipe unsigned here, it would work, but that's not exactly what we wanted to do. Anyway. Well, not very. No. Exact. Single point. Okay, where were we? So that's not right, but we'll fix that in a sec. This should be similarity. Yeah, so debugger would be nice at this stage. You can see all my lovely print lines everywhere. Okay, so it's the first one here. And the first one is coming up as a... That's strange. So cast could be returning the wrong... Cast is returning the wrong type. Yeah. Let's see. Let's do... We have this because we need to, we don't know if we have a call or a cast in some cases. When there's a single argument, for multiple arguments or certain other cases, we know we have a call, but if it's a single argument, we need to wait till the type check to check if it's a type. So let's do... where's our cast expression? So we got I'm pretty sure. Let's type the file name just so we know which file. Oh, okay, that's fine. Where are we going to do those promotions? Okay. That's not, it's not a solid check, because this is, that's not too bad. Let's do Let's do if, actually, do this out of the loop. If okay, that's better. Wait. No. Ah, it should be array. See, all this should, you can clean all this up into a few lines of code probably. come back and clean that. I'm not too worried about that. I'm mostly trying to implement as much as I can and then come back and clean it up. As long as there's on multiple levels of abstraction and multiple branches of checks and stuff that's hard to change, we won't get into that. Simple stuff like this, it's not a problem. Clean that up. Okay, so that's the right type now. And what have I done? Back to where we were before. No. String length. No. B. Okay. Repeat. Okay. Why is it? What is repeat? I think repeat returns void pointer. No, it returns array. Yep. Well, it's the same. That's what I mean. So, oh, length. Fuck, what am I doing? That's right. Found method repeat for array. Call method repeat. Found field length for array. Oh, we're different. Primitive. So it's not that. It's a different one. What is it? F dot A dot length. I really need to add a position. Just one of these. Mapping expression. So that's probably why we don't have a map init added in our Reddit. Just returns an integer or something like that. Yeah, look at that. the end of expression returns integer, unhandled map init. So let's add map init. So let's bring up the AST so we can map init will always have the type, so we can just return the type. Nice and easy. We're not going to type check the keys or the values for now. Let's add a note about that. Now, there's some cases in a map when you're, how do I say it? When you return, like when you're resetting an existing variable and you set it to like a equals, like that. And we'll handle that later. And we'll type check the keys and the values. We'll type check the values later, I mean, all the keys as well. I made map keys so they could be variable names, expressions. I don't know if that's even doable. Well, that's why I originally made them expressions, but let's forget about that for now. Let's just return the type. Nice and simple. Let's add a note to do type check evals return pseudo expression dot type. Okay, that should fix our problem. Well, it didn't fix our problem. Let's do actually. Map init, map string, integer, I cannot find. It could be, we might not have maps handled. That's probably why. I think I know what that is. Let's go to find field or method. Now we got array, enums, pointers, strings. We don't have maps. That's why. Let's add maps. T is map. Now it's a bit funny. This is one thing, I don't know who's listening, but this is one thing that there's got to be a better way to do this. Basically, in built-in, let's bring it up and have a look. Let's go. Let's open up maps. Okay. No. Built-in map. Alright. We have a type. Where is it? Struct. Map. See, we have this map struct. And this is the base for all maps. Like the methods, they inherit these methods. Now, same thing for string. There's a string struct. Now, we also have a type named string and a string struct type. So it's not ideal. And the way I'm currently handling that is if you look under arrays here, we look up the actual type named array, and then check for the methods on that type. Now we're going to have to do the same thing with maps here. Now, there's probably a better way to handle this. For now, we're just going to do it like this. We don't need that. So let's look up a map. Now this 0, that I'm going to get rid of this argument altogether. But I'll leave that for now. Alright, let's try this. Should fix this issue, I think. Or not. Let's So there's nothing to do with maps. What are we looking for? Length on a primitive. I need a line number. These shitty line numbers don't help. Let's try get a line number. Okay, so what we'll do is we can pass a position. Actually, we know we got the area here, position here. So let's add a position to selector expressions. Okay, let's add a position. Let's go to the parser. Let's find all, wherever we create a selector, let's add a position. Okay, there's one there. And there's one here. Yeah, we should be able to do expression of pos. And we should have, now this is still not going to have the right line number because we need to do that thing I was talking about earlier with the base offset, but we're going to have a column. That's good enough for now. We should be able to, yeah. What have I done? Token dot pos. Okay. Cannot find field or method. Why have we got no? Need to simplify this so it's just one call that can be reused or something. One, not that same thing repeated everywhere, even though it's for different types. Okay, now we have this offset in the file. Like I said, the line number is not going to be correct. That's because we don't have that file set and base offset set properly, so it doesn't. Anyway, that's irrelevant. we have an offset in the file, so let's just open this. Let's open it in Visual Studio Code. And 1394. 1390. This one. So it's A. Hang on. 90. Yeah, it's this one. It's this one here. So what's A? A is a string. Something could be wrong with how this is being passed. This could be, it's obviously passing this incorrectly. Let's copy this to the syntax test and see exactly what's happening. Let's just stick this at the bottom of our syntax test. Where was it? Okay, let's disable type checker for the moment. And let's run the syntax test. Okay, we want skip imports and skip built-in. Okay. Yeah, see this is passed as a selector expression with the left-hand side being array. Let's check that. So zero to 8. Actually, that could be correct. No. So let's check something. Okay. So this is our range. I think I just added range one time for debugging purposes. No, so that it looks like it's right. Fix expression. Okay, let's enable the checker again. Actually, let's just get rid of this range like that. Let's turn it into a normal range. There we go. Actually, let's put some spaces there too. Okay, it's better. All right. Let's enable checker again. Don't have infix. Okay, so something to do with if expression types not right. Has to be that. Yes, and there's the culprit, returning an integer. See, all this stuff's not finished. I mean, the base is there, but you can see like a lot of stuff needs work. But you can see how fast it can move. Well, it's not moving fast now, but you know what I mean. Oh, let's fix this then. So hang on. Okay. So we're going to check the types as well. We're not even checking the type of the statements. We need to do that in this, an assignment. Oh. Yeah. Yeah, we need to. All the types should match, so we can use the. No. If. Else. So we're going to get these statements. Okay, if, okay, last statement. Statements to last. Actually, first. If. Is expression statement. And this is irrelevant to this. It shouldn't be on that else. Just cut that. Let's just return this for now. And just see if our error went away. Statements. Hang on. Statements there. Okay. Did we move forward? Looks like we moved forward a bunch. Or did we? Did we? Let's just exit that. Where were we before? Looks like we were. It's not far. Okay, let's just return integer like we had before. Okay, so we're on. Okay. Oh, look, we did jump forward a bunch, looks like, didn't we? Or did we? Easy check. Yeah, it's a bigger file. We move forward. Deref on non-pointer type builder. Two 775. 2775. I really need to fix those positions. It's this. Okay, that's simple. That's not handled, that's all that is. How long have we been streaming for? I think we'll call it. Come back to this. I'm going to call it. I'm going to end the stream. We'll come back to this. Progress some more tomorrow or something. Well, I'm working on this every day anyway, so. Just fixing bugs like this. I usually just go through, fix a bunch of bugs, go through, clean it up. Then once I think it's clean enough, I'll push a commit. And you can see how much work I've done without pushing a commit, because there's a lot of nasty stuff in there I don't want to push. So anyway, I'm going to end the stream for now. See ya.